Now, another term for the mean of a discrete random variable is the expected value. Now, if we look back at the previous problem that we did, where we were looking at the number of vanilla cones that Jason is able to sell in a day, we can write this, instead of saying on average, Jason sells 158.6 vanilla cones in a day, we could write that as an expected value. So the expected value is notated as E parentheses X, and it's the same exact thing as the mean. So we could say that Jason can expect to sell 158.6 vanilla cones in a day. Now, that doesn't necessarily mean that every day he's going to sell that many cones. But the expected value, the expect to sell, is the same interpretation as the average for what Jason is going to sell. So expected value is another term for the mean. And the application of the expected value is where the difference really is highlighted. So I have a few examples that we're going to go through. And the big difference with these examples is also that we're going to be looking at how to set up these tables, these distributions, from word problems. And we're going to be coming up with the expected value based on the word problems. So in this example, to raise money, a charity has decided to raffle off some prizes. The charity sells 2,000 raffle tickets for $5 each. The prizes are 10 movie packages worth $25 each, 5 dinners for 2 worth $50 each, 2 smartphones worth $200 each, a TV and a TV worth $1,500. What is the expected gain or loss if you buy a single raffle ticket? So taking a look at this, they sell 2,000 raffle tickets and they sell them for $5 each. Both of those pieces of information are going to be important to setting up our table and our expected value. So the prizes, we have 10 movie packages and each movie package is worth $25. We have 5 dinners for 2, each worth $50. We have 2 smartphones worth $200. And I'm going to find a lighter pink. I have a lighter pink in here somewhere. There. Let's try that one. And then 1 TV worth $1,500. So what is the expected gain or loss if you buy a raffle ticket? So we're being asked to find the expected gain or loss, the expected value. So because we're being asked to find the expected something, we need to find the mean of a probability distribution. So the easiest way to find the mean of a probability distribution is to start with a table. So our table is going to have X values, where X represents something, and then we're going to have probabilities. And so I'm going to set up my table. And I need to figure out what my X values are going to represent. I need to figure out what my probabilities are going to be. And I need to figure out a whole lot more stuff. Okay, and I'm going to extend this table over because I'm actually going to have a secret third column. And it's my secret third column that's going to help me figure out the rest of this. So in this case, the prizes are items, and then the items have a monetary value. So this third column is the outcome column. And in this case, it's the prize that I've won. When we're calculating these expected gain or loss problems, we won't always have this outcome column. But in this case, we do, and it's super helpful. So the outcome of us getting our raffle ticket chosen is a prize. That prize comes with a monetary value. So the random variable is the dollar amount of the prize. That is what is randomly changing based on what we win. And then the probability is how many prizes are there out of how many raffle tickets there are. So the different prizes that we have the movie package, we have the dinner for two, we have the smartphone, and we have the TV. So the movie packages are worth $25 each. The dinners are worth $50. The phone is worth $200, and the TV is worth $1,500. For the probability, there are 10 movie packages, and they sold 2,000 raffle tickets. So 10 out of 2,000 is 0.005. There are 5 dinners, which is 0.0025. 2 smartphones, 0.001, and 1 raffle ticket, 0.0005. But now I'm looking at my table, and remember, a probability distribution has to sum to 1, and this definitely does not sum to 1. So we're missing an outcome. And the outcome that we're missing is that you win nothing. And so the dollar amount of your prize is 0. You didn't win anything, so you walk away with a dollar prize of 0. And to find that probability, I'm going to take 1 minus 0.005 plus 0.0025 plus 0.001 plus 0.0005. So I'm using the complement rule to find this missing probability. So the probability that you walk away with nothing is 0.991. So now I have all of my outcomes, I have all of my x values, and I have all of my probabilities. So the expected gain or loss is the mean. So I'm going to calculate the mean just like I did before. 25 times 0.005 plus 50 times 0.0025 plus 200 times 0.001 plus 1,500 times 0.0005 plus 0 times 0.991. And I can do this all at once in my calculator so long as I'm using parentheses for my multiplication. So if I just type this in exactly how I wrote it, my calculator knows the correct order of operations to do. And that doesn't look right for some reason. Hang on one second. I don't like the answer that I got. I don't remember that being the answer. That is the answer. Okay. 1.2. So that's what we get when we calculate the mean, but we've got one little piece left, and that is the $5 that we paid to enter this raffle. We haven't taken that $5 into account yet. Now, I could have taken it into account when I thought about the dollar value amount for each prize. I could have subtracted $5 from every single dollar amount, but that would have been a lot more work. So what I'm going to do instead is here at the end, I'm going to say, all right, I've got the mean, but I need to take $5 away from the mean because it cost me $5 to pay for my raffle ticket. So really, the expected value is negative $3.80. So because it's negative, there's an expected loss of $3.80 in this raffle. Which is great for the charity, not so great for you. But good for the charity. They want to make money, so they should have it so that you are not profiting off of their charity raffle. So let's look at the second example, which I gave a lot more room for. A home insurance company sells a policy for $500 to insure a house for $250,000. The probability of the house being destroyed is 0.015, and assuming either complete destruction or no destruction, nothing in between, what is the insurance company's expected annual profit for this policy? So in this one, they're selling the policy to you for $500, and then they're going to give you $250,000 of coverage. The probability of your house being destroyed is 0.015. So what is their expected annual profit on this policy? This would be a good time to pause the video and see if you can at least get the table set up for this problem. So pause for a second, give you a chance to pause the video. And we're back. I really hope you paused the video, took a moment, tried to set up the table. I'm going to go ahead and set up the table now. We have outcomes. We have our random variable x, which again is going to represent money. And we have probabilities. Ooh, this one's a little bit trickier. If you were able to set up this table, I'm very impressed. So our outcomes, we have two possible outcomes. We have either your house is destroyed or your house is not destroyed. If your house is not destroyed, you paid $500 and that was it. So they made $500 off of you. But your house wasn't destroyed. So that's great. If your house was destroyed, however, the insurance company ended up paying you $250,000. So they are in the hole negative $250,000. But they didn't start at zero. You first paid them $500. So they're actually only out $249,500. Because they started at positive 500 from you. And then you lost your house in a house fire or a flood or a hurricane or a tornado. It doesn't say. You lost your house. So they have your 500 and then they have to pay you 250,000. So they are not starting at zero, they're starting at positive 500. So that's why it's a loss of $249,500, not the full 250,000. So then the probability that your house is destroyed is 0.015. The probability that your house is not destroyed is the complement of that, 1 minus 0.015. Because either your house is completely destroyed or it's not. There's no in between on this one. They're either not going to pay you anything or they're going to pay you for a full loss of your home. So that is 0.985. So now we calculate the mean. Negative 249,500 times 0.015 plus 500 times 0.985. Do not lose that negative sign. That negative sign is going to make a big difference. A really big difference, because this is actually not a profitable insurance policy. If this company wants to continue in business, they need to up their premium, how much they're charging. Because right now they're losing over $3,000 on this insurance claim. on this insurance premium. That's not good. And the reason is the probability of your house being destroyed is actually really high. That's a high probability for one of these questions. 0.015. I think maybe there was supposed to be a percentage on that, and so we would have moved it two more places over, but it's not there. So I just went with what I saw. But I have a feeling this drive was supposed to be a percent. So I bet if we turned it into a percent, we would have seen a profit. But that's okay. So there we go. Expected value. Same calculation as the mean. All we do is interpret the answer a little bit differently.